Tinybird. And okay, so let's get started. So Tinybird, very quickly, the problem we set out to solve is that as data keeps growing, analyzing it in real time gets harder and harder. It is very costly. It is usually painful because it involves huge amounts of data and machines, normally in different clusters and different sets of services from cloud providers and things like that. And it's also very inflexible in the sense that whenever you want to, you're doing a lot of pre-aggregations, if you're doing a lot of ETLs, whenever you want to add you want to solve new problems, you need to filter by new dimensions, you want to join with new data, then you have to go back to those ETLs, back to all of those processes instead of just solving the problem. So we always say that the actual data engineering, while it's something we're very used to and that we do a lot and we've worked with a lot of data engineers, is not where the intrinsic value for the businesses lies. Where it values is in delivering answers and solutions to business problems. And so we want to make the lives of the developers and of the data engineers much easier and much more productive. So that's what we set out to solve. And in the process of doing that, we also realized that companies are waking up to what we call the real-time data upgrade. We've realized that there's a lot of companies that live with long-running ETLs and batch processing as one lives with white noise in the background as something that you're used to it, but not necessarily is not necessarily what is the best for all use cases. And when you start realizing that you can have 10 to 1,000 times performance increases, you start realizing you can work in a different way and you can do things very differently. Tinybird is a very flexible platform that you can use for many different things. And but here are some of the 3 use cases we see more and more. One of them is what we call in-product analytics, which is companies that have a product and want to show analytics to their customers. This is something that normally is not a problem it's not the core problem that company set out to do. And we provide a great way and very fast and scalable way to generate analytics for our customers, let's say. Operational intelligence is another one, which is when you have huge amounts of data coming in and you need to understand how your business is unfolding in real time, and you want to provide real-time dashboards, and you want to understand what's going on in the other side of the world. If you have a large operation and that everybody is looking at the same information so that they can take decisions based in the same information, it's another use case that we see more and more. And the last one we usually mention is process automation, which is sort of a derivative of operational intelligence. When you have real-time understanding of your data, you can then trigger actions that happen in real time that before you probably couldn't do because you needed to wait to understand the trends and then take the decision manually. Once you have real-time decision-making capabilities, you can change the way you operate. So in a nutshell, we like to say that Tinybird is the way to build real-time data products. We're with our product, we go from ETL to ELT. So we are focused on ingesting large quantities of data, and you can transform data on the fly. As data comes in, you can materialize and then use the data to then expose it, or you can do queries in real time to that incoming data. It's built to scale linearly, whether that's horizontally because you add huge amounts of data, or vertically because you have loads of requests coming in. We're very focused as well in improving the development experience when it comes to data products, and that includes bringing all of the techniques that as developers we've learned to deal with code and infrastructure, such as continuous integration, regression testing, version control, all of those things we are bringing to the data product development as well. This is something that for us is key, and the only way to really be efficient and scale products, no matter how scalable your technology is. You need to be efficient at using it. We use SQL, so you don't need to learn anything else. And we provide a serverless experience in the sense that you don't have to worry about how many machines you have in the background. We take care of that. And as well as security and other things, so you don't have to build your own backend for things that you can do directly with Tinybird. And lastly, we also provide an observability layer out of the box, so you can understand what's going on with usage of your platform. And just to give you a quick diagram of where we fit in the picture, we understand that there's a lot of companies that already have a data warehouse, and where for most of those use cases like batch exports or data science or BI, it doesn't matter a lot if ETLs take minutes or hours. Queries can take seconds to minutes because you're not constantly running them. But there are a number of use cases that where you want your data to be real time, and that's where we come in. We can take data directly from CSV files, data streams, or connect to transactional databases, and we can take data as well from data warehouses when we want to enrich data, for instance, and we can provide that ingestion in real time and then expose API endpoints with very low latency, such that you can build highly scalable data products, operational dashboards, automations, alerts, things like that. So today, what we're going to see is a modified version of this. Essentially, we understand that there are a lot of companies that are already storing huge amounts of data in data warehouses like BigQuery, and you know, there's huge value in that data to do, for instance, in product analytics or for other use cases. But when you want to build a data product on top of BigQuery, you run into a number of problems. First, you have to build your own whole backend and access policies and basically the whole application. And also, BigQuery is just not priced or designed to handle hundreds of requests per second. So we are working with a number of customers doing these kinds of integrations where we provide sort of the publication layer, the acceleration layer, we like to say, for BigQuery or other data sources. And at the end of this, we'll be showing you how it all ends up in a little application, which is this one that I have right here. It's an application built in JavaScript, hitting our endpoints directly. This one is the data that you're showing is from a previous, from the preparation for this webinar. But what you will see is that we're going to start ingesting data from scratch, and then we'll point this application to the new endpoints so you can see how data comes in, and we report on it in real time. So with all that, I'm going to pass it over to Alberto, and he's going to start with a demo, and he will explain from the beginning how we do this. Alberto, all yours.
I have a problem because I have an error message that says that host disabled participant screen sharing. I don't know if you can do anything with that.
You see, I don't understand why this is going on. Sorry, I'm new to Zoom. So, panelists, there you go. Alberto, make host. I'm going to give you hosting capabilities.
Okay, now I can.
Okay, great.
So you see my screen, right?
Yes.
Okay, so we're gonna build the backend for this application from scratch, and we're gonna be using BigQuery, as Jorge said, Tinybird. So from the point of view of BigQuery, we have a data set with these 5 tables. The main one is this invoices table, which has 40 million rows, and basically it collects payment transactions. And it's interesting seeing the schema because the actual payments are stored in a record, what in BigQuery is a record, and we'll see how we can unroll these payments in a few minutes in BigQuery. And there are references to another dimensions tables, agent, client ID, recipient code. We have these dimensions tables here. And so first thing we're gonna do, we're gonna be in Tinybird. I'm going to create a new workspace. And a workspace is a place where we're gonna push all the data sources and endpoints. And I'm gonna invite Jorge, Tinybird. Because basically you can have collaborators in the same workspace. So the third tool I'm going to use is what we call the command line interface. So most of the demo is going to be done in my terminal, but we'll be jumping to the user interface to check some stuff. So let's start with the project. I have this GitHub repo, which is public, which contains what we call the data project. I'm going to clone it, and I'll show you the contents in a few minutes. Basically, we at Tinybird, we organize projects with this folder structure. What we meant with a data project is a way to organize how you store your data, how you transform it, and how you publish it. We'll see in a few minutes what's in each what's in there in each folder. And first thing you have to do when you have the data project is installing this command line interface. I have it already installed. So the first thing is to authenticate your local session with your Tinybird account. So for that purpose, you run this command up here, and we can take from the workspace we just created, we can take the token. So we've connected this data project to this workspace. So we have here a set of commands to basically make everything you need to do to work with the project. You can do it from the command line or from the UI. And for example, I listed the data sources in my workspace. It's now it's empty, but we're gonna push the whole project right now. So first of all, let me show you what's in there. We have 3 different folders. One that contains the data sources schemas. And as you see, we have mainly one file per BigQuery table, which basically map the same schema as the tables in BigQuery. On the other hand, we have a pipes folder, which basically do some transformations over these data sources, because sometimes when you are running analysis, you need to perform some pre-aggregations, or you need to prepare your data, let's say, for your specific use cases. For example, in this pipe, what we are doing is converting the currency for each invoice into euros, and the result of this is being persisted in what we call a materialized view, which is a different data source. For example, this whole query, when it's run, it's being persisted in the invoices MV data source, which is this one up here with this schema.
And one thing that is worth mentioning is that once you create one of these materialized views, as data comes in, it will store the result of that query, basically incrementally in the new materialized view. So the views not being calculated constantly is only being calculated incrementally as new data comes in.
And finally, we have a folder which we call Endpoints, which actually have the queries over our data sources that we are going to publish as a REST API endpoint. We have several here prepared. If you see the original application, we had a chart with the payment evolution per month. We have a total amount of payments and several ranking for agents, clients, and recipients. All these widgets, let's say, map with with one of each, one of these endpoints we have here. So now what I'm going to do now is to this data project that I have locally, I'm going to push it to my Tinybird workspace. We can do that with a single command, this one here. So what this is doing is looking at the folders in my data project and pushing the entities to my workspace. If we go here to my workspace, okay, we now have the different data sources. I think there's one error in this total amount I.
If not, get rid of it, and we can always create it in the interface.
Yeah.
So we don't. Yeah, we added this one in the last minute, and that's what happens.
So okay, we can string indices must be integers. Oh. I don't know what this means.
If not, if you don't see it right away, we can you know, we can change to the other one that we ran earlier and truncate the data and then start from there. That's unfortunate.
Okay, so yeah, we can. I think we can continue from here. So okay, let's say we have pushed the data project. So next thing we have to think about is, okay, we have some data already here for each of these tables. We have our dimensions tables, and we have some data in our invoices table. So first thing we have to do is to do a first import to Tinybird. So for that purpose, we have an utility here in the command line that allow us to export data from BigQuery to Tinybird. So what you have to do is to authenticate the client with your BigQuery project using a service account I have already configured. And from now on, we can, from the command line, we can run a query into BigQuery that exports data to a Tinybird data source. So I'm going to truncate this one, for example, which is empty right now.
Is the token the right one, Alberto?
Yeah.
Cool.
Oh, sorry. I changed the workspace, so it's not. Sorry.
Yeah, that's what I was thinking. So that probably went correctly into the previous one, but since you're in the new one here.
So. So that's it. So this, For dimensions table, this is quite straightforward because, I mean, this has very few rows. Let's see if we do a count. This is 25 rows, but how we do ingest data into the an events table, in this case, invoices. Let me truncate this table as well. And I'm gonna truncate the related materialized views. So with the very same command line tool, I'm gonna, for example, load data for a couple of days of this table. So instead of loading the whole table, I'm filtering by a date. And in this case, I think it's gonna load like 300,000 rows. And what we're gonna see here in the dashboard is that we have a one running job, a one running import job, which basically what it has done is taking CSV that has been exported from BigQuery to Google Cloud Storage, and it has been ingested into this data source. If you take a look at this error message, it says that there have been 80 rows in quarantine. And we can take a look inside the data source. We have here information about rows that don't match this data source schema. In this case, it is because when BigQuery exports the data in chunks, it includes the headers in different places of the CSV file. But the nice thing about this is that we've discarded these, we've automatically discarded these wrong rows, let's say, but we've finally ingested the rest of the valid data. So with the scenario for this tool is, let's say you want to schedule periodic ingestions over BigQuery. So the thing to do is to either using, I don't know, a cron job or a GitHub action or whatever tool you have to run to schedule jobs. You can execute this kind of queries, filtering by date each time. So what I'm gonna do now is to load the rest of the data for this invoices table, which is gonna take 20 gigabytes of data. And in the meanwhile, I'm gonna let Jorge to show us the user interface and
the only thing is, Alberto, you have to invite me to this this one, because you invited me to the new one.
Right.
So if you do that, I will log in, and you have my email there, everybody, if you want to send me one. All right, so here it is. I'm going to join, and while you finish uploading all of that, I will share my screen here. You might have to.
You can start sharing right now, right away.
You have to make me the host. If you go to the participants list and go to panelists, make me the host, please.
You got it.
Okay, sorry. Screen. Okay, excellent. All right. So while the rest of the data gets ingested, I wanted to show you a few more things, which essentially these are all of the tables that Alberto was showing. It's interesting to see that there's this job in the queue that is still working, and we can see how, if we come in, for instance, we can see here what's going on in the data sources log, and we can also see how the data gets not just ingested here in invoices as it gets created, but also how data gets materialized. So from here, for instance, if I create a pipe and I do a count, then this count, you can see how it's constantly changing. This also means that if we build an endpoint on top of this data, this endpoint will be always up to date with the latest available data. So as data keeps coming in, it can be immediately available to display in endpoints. So let's look at one endpoints. Let's look at top agents, for instance. So this is a query that we prepared here. This API, these pipes are like Jupyter notebooks. They are like working documents that you can document as you go, and that you can divide in different chunks to make your work easier. So we have a description here. This accepts Markdown. You have a couple of parameters here that you're going to see in a second. As you can see, it has a page and it has a page size. This is so that we can do paging. And you can see that in the query here, there is a templating kind of language, which enables us to create parameters. It enables us to do, like these parameters are being used here to build a basic paging mechanism. But you can use them to do, if you look here, you can do conditional statements. You can do add, make it required or not required. You can throw errors as well. So you can use all of these to make sophisticated API endpoints. And once you have this, you can then turn it into an API. Once you've done your query, this is already published as an API. And if you come here to View API, it gives you all of the information about this endpoint, how many requests it's had on the last 24 hours, average latency, if it's had any errors, then the information about the parameters, and then an example, the URL, some example integration options. You can also consume it as a CSV if you prefer. And the interesting thing here is that we're building this so that it's very easy to build applications against. So if you click on share documents here, you can create a unique link for this specific API endpoint, but you can create tokens that give you access to a number of them. If I copy this would be the perfect URL to share with a developer. This is just for the top agents, but it includes the information we've created, automatically documented parameters, the same examples. It has Swagger or OpenAPI integration. And if you go back to available API endpoints, you get all of the API endpoints that this token gives you access to. And if you're building a specific API product, you can create a token that gives you access to all of those endpoints, share that with your developers, and that's all they need to start building. So Alberto, how's it going on your side? Should we continue?
Yep. I'm
all right.
gonna share my screen.
Let me know if it allows you to do it or not. I'm gonna stop sharing here. If not,
you have to make me host again.
Yeah. There you go. You're the host now. You're the captain now.
Okay, so until now, what we've seen, we had here a data set in BigQuery with a set of tables. We've been able to map those tables to data sources in Tinybird. We've been able to connect the data to ingest from BigQuery to Tinybird. We can do it from the command line. We can schedule recurrent or periodic ingestion processes. But now we're going to see a different scenario for ingesting. which is something we've seen lately, and it's very common in a scenario like a streaming scenario. So it's very common having your system, specifically in this kind of use case where you are processing payment transactions, in which you have an event streaming platform where you publish your events. So the typical use case is you have a message queue. It can be Kafka, it can be, I don't know, Google PubSub, like in this example. You do some stream processing and you store your events in BigQuery. So basically you use BigQuery as a data warehouse where you can do batch analysis or whatever. What we are doing here is connecting Tinybird to this kind of stream processing workflow. So for this purpose, we are using Google DataFlow, basically because it works nice with BigQuery and with the ecosystem. But what you need to know is that DataFlow is just a runner for Apache Beam. So what we have here is a workflow that reads from a Google PubSub topic, in which we are right now publishing like 80 or 100 messages per second, which are invoices. These messages are going through this pipeline in which we do some stream processing. And on one hand, we store the events in the invoices table, and in the other hand, we send the invoices to our data source in Tinybird. In this case, we want to also showcase a typical streaming scenario in which we have added a stage for buffering data. So instead of every time an event arrives to the PubSub, instead of sending it to Tinybird, what we are doing here is buffering, I guess it's 15 seconds of messages, or 1,000 of them. So we do some buffering, and then we do the ingestion to Tinybird. This allows us to stream the data as it comes in, compared to this other scenario in which we haven't added batching. And as you can see, BigQuery is I mean, the wall time, which is the time that BigQuery needs to ingest all the data, is a little bit higher than the one needed when you use buffering. So this is important to take into account when you run streaming ingestion in any platform in general. So what we can take a look now is in our original invoices table. If we go to the log of ingestions, we can see the buffer was 5 seconds instead of 15. So every 5 seconds, more or less, 5, 6 seconds, 7 seconds, we are receiving an ingestion coming from Google PubSub with a few rows, depending on the load of the queue. And the interesting thing about this is that we had a couple of materialized views, as we saw before, and they are being pre-aggregated as data comes in. So as you can see, for example, if we calculate the total amount of payments, as data is coming in from the streaming from Google PubSub, it's being recalculated. So in the end, if we go to our original application, we've been doing 5 seconds polling to our endpoints. And what we are seeing is that as data is being streamed to Tinybird, we have updated data from our API endpoints. And I don't know if Jorge, you have anything else?
Yeah, no, that's it. Really, we had this very exciting moment planned where the application was going to be using an empty token, and then we would switch to the new one, and you'd see how it suddenly started working. But because we had that problem, we had to go back to the original account where we prepared the session. Then, well, you can see it how it's updating now. That's essentially what we wanted to tell you. What we've seen is for us it's very straightforward to build applications based on large amounts of data, and getting data from BigQuery, whether it is using our connector to do it in a sort of a regular intervals, or whether you want to make it more real time using Google DataFlow and data. We're using PubSub for this example, but it could be data coming from Kinesis, or it could be data coming from different systems. It's a really good way to accelerate all of that data that you might be storing in BigQuery for other use cases, but in order to build then API endpoints you can exploit to build applications like this one. This is obviously a very, very basic one, but you get the idea. And we are only making like a query every 5 seconds, but we could be hitting this with 100 queries per second. Another thing very interesting to note as well is that all of this demo we've done on a standard account. There's no it's not scaled to any particular specifications, and as you can see, it deals with loading data in with no problem, and we can hit it with a lot, even in the standard configuration. So that's what we wanted to show. I don't know if there's we had a question. I don't know if there's any other questions you guys have. We'd be happy to answer. And we'll also prepare this as a video, and we'll send you some follow-up materials, like for instance the source code for this application, so you can see how this is just basically an application hosted in Vercel, and very like a one-pager, and but you can see how the endpoints are being used. And we'll also send you the repo for the data project that Alberto has been using to basically build all of this that we've shown you. And that's really it. Let's give it a minute to see if there's any questions coming in or any feedback other than the horrible demo effect.
Yeah, about the data types and how we map, how we sync data schemas. In the data project, we have the specification of the schema of each table in a separate file. So, for example, if we go to the client's table in BigQuery, it has a company country, a company name, and ID of these types, and this matches. Let me put it together. This matches the same schema in the data source we push to Tinybird. And then when you do the ingestion, for instance, for this table, you do it in a way that the query you use to export data from BigQuery matches the name and type of, and the name and the order of the columns in the schema of data source. So this is how you map BigQuery tables to Tinybird data source. And this file, for example, the client's data source, it's something you can write by hand if you know the name and the data types, or we have an utility. Let me see if it is this. We have a command to given a sample CSV, we have a command to automatically generate this data source file. So basically, it infers the schema from a sample CSV file. So if we open this CSV file, for example, you see it has a header with the name of the columns, and it infers the type from the sample. So basically, you can quickly, from CSV samples of your tables in BigQuery, you can quickly generate these data source files directly from the command line with this command.
I'm answering a question here. Yeah, so basically, rather than typing, I'll answer here. So Imanol was asking that we talked about incremental growth of the materialized views, and if we could please explain a little bit more about how this process works. So essentially, Tinybird uses an open source database called ClickHouse. Under the covers, it's a incredibly fast and powerful database. We always say that it's like a Formula One, that it's you know, if you have been driving for a long time and have a team of engineers and mechanics, then you can make it run very fast. But what we're trying is to simplify all that process. And how this works in terms of materialized views is we can specify that the result of a query will to one table or a number of tables. It could be the result of a join, or it could be whatever you want, or an aggregation. It will calculate, it will put the result of that query into another table. And as data comes in, ClickHouse takes care of of keeping the result of that query valid in the materialized view. But what happens is we also have built functionality on top so that you can replace part of the original data and it will change it in the materialized view, or you could delete part of the original data and it will take care of doing it in the materialized view. And we take care of that whether the data is replicated across different machines, or however it's done in the background. It's nothing that you have to worry about, basically. Hopefully that answers your question. I'm not sure. I don't think we have any more, so I think we can leave it here. Thank you very much. That was really great that you joined. Feel free to email us, and my email is jorge@tinybird.com, and or just email. What just happened here? Shit. Oh, did you close? Oh, sorry.
I thought sorry.
I thought you finished the webinar. So anyway, feel free to get in touch, and we'd be happy to have a chat or understand your use case and help you hopefully set up something like this. All right. Thanks, everybody.